A typical trait of responsive websites is snapping between breakpoints. That's what you're seeing here when we are snapping from a smaller font size to a larger font size. This is because the developer has to make choices about things like font size and layout for different viewport widths. And these choices have traditionally been rigid and codified in media queries, like you're seeing in the code example here. As a result, we get a setup like small screens get a base font of 18 pixels, larger screens get 20 pixels, and even larger screens get 24 pixels. And as the viewport is scaled up, you'll see the font snapping from one size to the other. This works fine, but it's a jarring user experience, especially if the user is not expecting it. Now, using the min, max, and clamp CSS functions, we can introduce more flexibility and nuance into this situation. So let's take a closer look at these functions. First, I'm just going to get rid of the media query here, because we don't need it anymore. We'll replace it with these functions. Then let's look first at the min function. Min can be applied to anything that has a size. So in this case, I'll say width and min. And this function lets you provide a comma-separated list of one or more sizes, and the browser will then pick the smallest of the sizes available for any situation. So in my example, I'll set up 40ch and calc 100 VW minus 2 rem. All right, what happens now is the container width will be either 40ch or the full viewport width minus 2 rem, whichever is the smallest. So if we go and look in the browser, you'll see what that means in practical terms. When I scale down the viewport width, so it's less than 40ch, then the second condition kicks in. So in this case, we are now looking at 100 VH minus 2 rem. But when I scale up, 100 VH minus 2 rem will be larger than 40ch, and therefore 40ch kicks in and locks the width of this container. So that way, we've created a responsive and scaling element without using a media query, where a media query would normally be necessary. And we have really detailed control over exactly what happens. And like I said, the min function can take many different comma-separated values, so you can very tightly control how this container scales depending on the current available space. Min always picks the smallest or shortest value. The max function does the exact opposite. So let's comment out this line here and set up a new width and set that one to max. Max works the same way as min, just in the opposite direction. So if I set the value here to 50 VW, that's 50% of the viewport width, and also 20 ch, we get a slightly different behavior. Here we're now telling the browser the container will be either 20 ch wide, or it'll be 50% of the full viewport width, whichever is the biggest. So if I save this and do my scaling example again, you'll see that when we add a smaller scale, the container will be 20 ch, because we're saying the bigger of the two values here is 20 ch, because if we set it to 50 viewport width, it would be less than 20 ch. But as I scale up the size of this container, we'll get to a point where 50% of the viewport width is higher or longer than 20 ch, and in that case, 50 VW takes over. So we're getting responsive behavior just in the opposite direction of what we had with min. With min, we are effectively setting an upper bound, and we're saying you can do all sorts of weird things, but here's an upper bound. You can't scale beyond this. Whereas with max, we're setting a lower bound and saying that you can't really scale any lower than this, but as you go higher, you can keep making things flexible. My recommendation here is to experiment with these values, slot in some different values, and see what the behavior is like. And then as you're moving forward and trying to use this in your own projects, think of it like that. Min is usually used to prevent an item from growing too much, whereas max is used to introduce more flexible sizes at larger sizes. Which brings us to the third function, clamp. And this is probably the most interesting of the three. So let me just change my code example here so that we have the min set up again. A clamp literally clamps a value between an upper and a lower bound or limit with a variable preferred value in between. This is what it looks like. So I'll go into my element and say font size, where it's normally used, and then we'll say clamp. And then we need the lower bound, so that is the smallest size the font will ever be. We can set that at 1 rem. Then we need the preferred value. So that is the flexible value that we want to target whenever possible. And I'll set that to 3 VW. Now that is 3% of the viewport width, which sounds weird until you see it in this context. And then finally, we have to set an upper bound, so the largest a font can ever become. And just because I'm working with a really small screen here, I'll set that to 1.4 rem. So effectively what will happen now is as I scale the browser, the font will never be smaller than 1 rem. If it's between 1 rem and 1.4 rem, the browser will try to scale it in accordance with the available viewport width. So you'll get this interesting experience of increasing the font size as the browser window increases. And then when we hit 1.4 rem, which is the upper bound, then it'll stop growing. So save this. As you can see, we now have the smallest size, so this is 1 rem. And then as I start scaling up the browser window, at a certain point, 3% of the browser viewport width will be larger than 1 rem, and then the font starts growing. So you can see the font is growing here. And then at a certain point, we will hit the upper bound. Let's see, I might have to increase my browser width to make that apparent. So now we've hit the upper bound, and the font size stops growing. So now we've created this really dynamic, fully scalable font that will try to be responsive whenever possible, but still has a lower and an upper bound, so it'll never be too small and never be too large. And that's what makes this function so magical. For the first time, we have true responsive scaling of fonts thanks to this clamp function. Now, all these functions, min, max, and clamp, are fairly new, and we don't really use them much in production yet, but they are fully supported across all modern browsers. So you should use them whenever you have a chance, especially the clamp function because it gives you this nice dynamic typography. But I highly recommend trying out these functions and really familiarizing yourself with them because they will solve many problems that you previously had with media queries, and they'll come in and help out solving all of those snapping issues that you had, because in many cases, you don't actually need a media query. What you need is min, max, or clamp.